Look, I've come through a convoluted pathway, I suppose. I've actually got an environmental science degree from La Trobe, and then I worked in local government for 10 years. So the way I came to Lixia in particular was through relationships built in local government and with the university, and having an interest in electronics, in data, analytics, and using the data for something good. So one of the things we see a lot is that a lot of data gets collected and it gets shelved somewhere away and it never gets used again, or shared for that matter as well. So we love sharing our data where appropriate and where possible to get it out as wide as possible to get the maximum benefit.
And prior to being a part of Lixia, I understand that you had a very different background. Do you see those background skills complementing the work you do here in Lixia?
Look, absolutely. So interestingly, my work in catchment management, water resource management, and then trying to use technology in the water business actually flowed in quite nicely into Lixia. So one of the things that's also quite apparent sometimes with technology companies that they've got very bright minds for electronics and data analytics and all these other aspects, but the domain knowledge about where the sensor's actually collecting the data from and what that data means is sometimes missing. So for example, we are very much focused on the flood monitoring space at the moment, especially for flash flood monitoring.
Very big in Queensland.
And New South Wales, Victoria, and quite frankly, but across the world as well. So we're not necessarily just looking in Australia. Basically, look, working in catchment management, water resource management, actually worked really quite well coming into Lixia and understanding how sensors, what data sensors should be collecting at what accuracy levels as well. So sometimes what's been overdone in some instances is the accuracy of things. For example, is it really useful to collect millimeter exact river data?
Absolutely.
And at a very high cost? Or can you dial that back a little bit at a lower cost and get many more sensors out there to get a much more complete picture as a firm catchment overview? So from my background as well, it's very much a comprehensive view, so like a systems thinking approach that really works if we're trying to collect environmental data, because we can then also look into what other data points would be interesting to complement that picture.
Absolutely, and I love that you mentioned systems thinking, because that's an extension of design thinking skill sets. So understanding how the relationship with these big system problems work, that's very foundational. So you're innately a problem solver. And this is where I think I'll go into a little bit more detail when we talk about skills in a bit, but let's talk about Lixia. Can you tell us exactly what you do for the listeners being mainly education teachers and students want to learn always about what are the cool companies in the region doing? And this statement of living infrastructure, that's awesome. So tell me a little bit about that.
So, and I'll go back right at the start. So initially, Lixia was spun out of Rockfield, a company in Townsville, and James Cook University. So our four founders have got very solid backgrounds in those two companies. And the idea was to create devices and systems that can collect data from infrastructure assets at a lower cost that was historically done. So, you know, quite frankly, putting $50,000, $100,000 sensors on bridges, power poles, all those sort of bits and pieces is cost prohibitive. You just can't do it. So you only ever select a few, and you inherently always miss some of the problems that happen. So Lixia was really designed to, or created, to address that shortfall, the sort of that gap between really high-end sensing to, you know, your sort of backyard sensing, and we sort of fit in the middle, I suppose, you know, where we build robust and accurate sensors, but accurate to a certain level where we don't go to the nth degree. Now, initially, we were looking very much at the infrastructure in terms of bridges and railroad infrastructure. We then moved into utilities, so power poles. We very much we worked with Energy Queensland to assess their timber power poles for movements and failure modes. From there, we actually moved into environmental monitoring to understand what the natural infrastructure is doing. And the term living infrastructure is because we want to create a digital skin about built assets and natural assets to really inform us how things are going.
And it's actually a shout out to, and I interviewed Govinder on my podcast, he actually mentioned living buildings, smart buildings, and a whole array of how these engineering bits and pieces come together. So this is almost seeing that work coming to fruition, so it makes a lot of sense. And tell me a little bit about what makes you an IoT company. Now, the reason I asked that question is a lot of people have heard the term IoT. It's a very much a thrown around concept and terminology. But most people associate IoT devices as smartphones or their fridge or their car or microwave or whatever. What makes yours an IoT device?
Absolutely. So one of the things we're really looking at is to collect real-time data from many assets in the field. So one of the things that really stands IoT apart from traditional monitoring assets is that we are collecting data from the field in real time from many places. So the idea is that we build devices at a cost point and utilize devices. So we don't always have to build everything. If there's something off the shelf that's appropriate, we absolutely utilize that. And the idea is to collect all these data points from across many sources and combine them in the internet, in the cloud services to actually produce analytics and outcomes and insights from this information.
And that's what's obviously driving the live feedback so that someone can at any time given understand the realistic point of view of things.
That's right. So one of the things that traditionally monitoring is always sort of a snapshot in time. It's a bit like my analogy is always water quality monitoring. So to go out water quality monitoring, for example, there's a local lake basically where the local government, the council basically goes out there once a week and takes a sample at the same time every day, and they get a great picture of what happens at exactly that time.
Very labor intensive.
They miss everything in between.
Absolutely.
So there could be short spikes of issues that are coming along that we miss, right? And it's got to be at the right price point. So that there is no point putting out $10,000 devices that might wash away in a flood, or might get impacted by other influences. So what we're looking at is really not necessarily at the lowest cost, but at the appropriate cost with the appropriate accuracy to collect that information. And what makes us, I suppose, an IoT company is that we're also for want of a better word, a bit of a design studio. So we design solutions for people's problems, and we then create electronic gadgets and devices and analytic systems to really provide that information.
So you said a whole bunch of things that I absolutely love to hear. So the design studio concept, but you're also an advanced manufacturing component. So let's talk a little bit about that advanced manufacturing part. A lot of students are usually interested in manufacturing context, but they're not necessarily always looking in the IoT space as a common one. So what exactly do you manufacture? Is it the actual sensors itself?
So look, it can be. So basically what we're doing is we do obviously buy quite a lot of gear in, but we utilize them and package them up and create new devices out of existing things. So for example, we use quite a sophisticated 3D printer to create enclosures and basically little gadgets that make our sensors work. But we've also got ramping ovens, so we actually get a blank PCB, so a printed circuit board, and we design our own concept and design of how these components will fit on this board. We put them on ourselves here, we test them. We've got a pick and place machine, which again, it's a machine operated little thing that puts components onto a PCB board before they get soldered on. So that's one particular part of what we manufacture, but then also again, like I said before, the enclosure design can be not just your standard 3D additive printing, but we've also used resin printers and other little gadgets there as well. So we always constantly look in technology to improve efficiency, but also rapid prototyping. So one of the beautiful things about advanced manufacturing techniques is really that we can prototype very fast and make adjustments on the fly.
And that's at a low fidelity point of view?
That's correct,
Perfect. And these are the common terms that classroom teachers throw around as well, so students are familiar with that type of terminology, but it's awesome to see that skill set being applied in the industry in a real world like this. So let's talk about the skill sets. Now, that's the part, that's what differentiates these career pathways at the moment. We're in a big evolution of context and new jobs being created, jobs that don't even exist right now. So when you're honing in on the actual skill sets required to work in a context like this, what would make a valuable employee, let's say in Lixia,
Yeah.
let's say in the next 5, maybe even 2-3 years even, what are the core skills you look at?
Look, one of the main things, to be honest, is being keen.
Being keen.
Be keen, be open to learning, be open to try things, and put yourself out there.
Yep.
Yeah. So there's obviously some core skills we need regularly, and so one of the things is really electrical design, electronics, so understanding those aspects. But I have to say, some of that can actually be learnt as well. So, like we said before, I've got an environmental science background, but over the years, I've soldered up PCBs, I've wired things together, so while that's not my core role, being a startup as well, we all have different hats on all the time. So what we're really looking for is people that are not necessarily, so we need generalists as much as specialists, like while it's fine, if you have a vision of exactly, I really enjoy doing this, and I could see myself doing that for a long time, go for it, absolutely. But if you're not sure and you go like, oh, I want to dabble in a bit of this, dabble in a bit of that, that's great as well. So because from my experience as well, you never know where life takes you with your skills and with your passions as well, So our staff is really quite diverse here. So we've had from many different backgrounds, I suppose. But one of the main things really is to be the ability to learn and to be open and to try, to not be afraid of failing. So it's okay. Like we build stuff here and stuff fails, and that's fine. We learn from that.
And that's part of the rapid prototyping context anyway. So.
Exactly. And there's other things. So we designed an air quality sensor for the Melbourne University, and that was probably our first sort of larger design project. And we learned a lot about just simple things like how long do things take. We had to write all the firmware, so we've also got software developers there. So it's not all just hardware. So that's the other interesting thing is from a company point of view, a lot of people look at technology companies and think, oh, you've got to be a really highly skilled tech genius. You absolutely don't have to, because there's the other things like, we've got office administration. We've got, we need to fit things together. We need mechanical skills. Of course, we need highly brilliant people like we've got over here. There's no question about that, but it's not necessary. So there's always areas in companies, startups as well as established companies, that require a broad set of skills, and it doesn't have to be at the highest level, because quite frankly, you get to the highest level by experience. You can go through university and do many PhDs, but quite frankly, until you've been on the ground and done the work, you don't necessarily know how well that learning translates into action.
Absolutely. And if you had to boil it down to a classroom subject context even, what are some of the subjects that you think would be complementing a career like this? At the moment, what's coming to my mind is the given STEM context, but I think design and technologies is a context. What's your thoughts?
Look, this sounds like a cliche, I'm sure, but coding's big up there. Coding, but mechanical skills as well. So because the thing being is, being a manufacturer, we need to make things. We don't just design things on the computer, but then we need to get hands on. We need to make them, and those are almost complementary, because what happens is that once you've designed it and then built it yourself, you understand much better how your design should improve to make your life easier down the track. So the mechanical aspects of classroom learning are important. The software side of things, like I said before. But then also the sciences, like we said, STEM, but not necessarily, technology, but like natural sciences are as important as anything else, because as I mentioned,
especially given your context,
as I mentioned before, but it's across the I think the industry in general is like everything gets deployed in the environment. So how does that interact, and what are we actually doing? What are we sensing? Does that make sense? So is there much point in putting all these sensors into this into this device and put it out there, knowing full well that realistically, that parameter is fine to measure, but it doesn't add anything. So it just adds cost and complexity. We can take that out, and if you can identify that early on in the piece, there's a lot of cost and time savings.
Yeah, absolutely. And this one of the questions that came to my mind while you were speaking was, in a tech company, what are the technologies that are actually part of it? Obviously, I'm seeing around your office that you have a lot of context there. You already mentioned 3D printing. What kind of software do you use?
Look, we use a combination of free and paid software. Again, being a startup, trying to save money where we can. But look, generic things. I mean, the Office suite, for example. But then there's also AutoCAD, for example, for design. But then there's also things like FreeCAD, which is free. But then also graphic design. So because again, being good at Photoshop, because we basically design or make a lot of our own communication products. Of course, sometimes we have to go to a professional marketing or design expert to get things done.
Yeah.
So graphic design programs, the 3D printers, luckily enough, mostly come with their own little design programs. But to go a step above there, again, that comes from Photoshop, that comes from other programs.
Any 3D modeling ones?
Exactly.
Yeah. Okay. Yeah.
And then, you know, but even accounting software, you know, like so Xero, MyOb, inventory management systems. So there's a broad range of software that's being used, and
yeah, absolutely. And what about the hardware type tech? So
Yep.
you mentioned 3D printing. Are there laser cutters here, CNC routers?
we don't, because basically they're generally large machinery that need to be operating all the time.
Yeah.
So one of the things that we're really looking for is what machinery can we utilize to the fullest extent. It's going to be cost beneficial for us. Luckily, again, Townsville, being a regional centre, has got a lot of manufacturing businesses here that we can utilise, and locals helping locals in a business sense is a great aspect there as well. Hardware-wise too, look, we've obviously got a mechanical workshop there, so we've got drill presses, we've got saws, grinders, sanders, you know, almost every sort of hand tool under
It's almost
the sun.
a makerspace in here.
That's exactly really what it is, because really where we're at is we need to rapid prototype to end up with a product that's useful to use, and even that. So we've got one here that is in its first version now, and we've just commissioned an injection mold for this actually to sort of get a bit more detailed in what we do. But all this is completely made here. It's it's hand welded. Some aspects are hand welded. It's painted. So the whole lot is done here. And what we need to do then when a product becomes successful, we then have to probably go to an industrial designer to understand how we can improve the efficiency of these things as well.
Yeah. I think that's a very good understanding of how those vast skill sets actually come together, because nowadays a lot of people, especially in a tech context or even in advanced manufacturing, you do need to have a broader skill set across multiple different avenues for that purposes of rapid prototyping, ideation, consistent iteration, etc. So for the teachers and educators listening, what's your advice for the teachers?
Look, this sounds potentially a bit weird, but instilling that sense of curiosity and really engaging with your students to understand that, give them examples of where things can lead. So one of the things that I keep saying is that I wish in my university days our statistics teacher would have explained a little bit better about what some of these things can actually be used for, and it goes back to year 9, 10 maths. It's like, when I grew up, when I was in school, I'd never had an idea why I would need these skills, or what does that mean? Like, I understand normal distributions of things, but then moving into statistics and then collecting data and wanting to understand, well, how does that correlate? What does that mean?
Yeah.
So very much looking at examples. So break it up. The theory is completely needed, but bring people to industry. Bring your classes. Go out and look at things. Make the effort. Contact companies. A lot of them are willing to bring your students through. I know we are, and really engage with the broader community to really get the purpose out there. So that the dry classroom learning can really relate to an actual action.
Yeah, and I think that's very important for students to understand. When you see the classroom skills by itself, you don't 100% of the time understand how it's going to be applied, and then therefore you disengage. Whereas if they're actually seeing this actual class skill sets being done in a very cool context, that's where I think the connection is, and you get the drive for it. So valuable advice. What's your advice for the students who might be keen on working for Lixia in future, or starting their own startup maybe?
Yeah, look, I think from a student point of view, just be keen. I know it's hard when you're a young person and school feels like a bit of a drag, but what you're learning there really is useful. Yep. You might not know for another 5, 10, 15 years, but you'll come back to that eventually.
Absolutely.
So for them, it's really be open, be engaged, be keen. Yeah. So what I've seen a lot, I suppose, in kids is that they're sort of a bit disconnected, and it really needs to. It takes effort and it's not easy, but you need to put yourself out there. Yeah. Like if you